Alright, so now we're going to talk about circles. Circles are the first of our 4 conic sections that we are going to talk about. They are called conic sections because they can be formed by slicing a cone. So that's what we see down here. If you take a cone and you slice it parallel to the base of the cone, you're going to get a circle. If you slice on a little bit of an angle, you get an ellipse. We'll learn about that. That's your next video. Slice at a steeper angle, you get a parabola. Slice vertically, you get a hyperbola. We're going to focus on circles right now. Circles are something we have done before. We did this at the very beginning of the school year. If you remember, we learned we looked at the generic form for a circle. We looked at how to identify the radius and the center. What is a circle? A circle is a shape in which every point is equidistant from a single point. That would be the center. The equidistance is the radius. So that was symbolic and beautiful because, we did this at the beginning of the year, now we're doing it at the end of the year, it ties everything together, circle of life, it's wonderful. But you're still asking yourself, you're like, okay, so besides the Lion King, when does this shape actually occur in real life? How do I use a circle? Why do I care about a circle? Valid question, but if you Google circles in real life, you'll be like, whoa, wait a minute, these actually do show up. Question for you here now. Because we see something like this, a soccer ball. Well, that's actually a sphere. What came first, the circle or the sphere? It's different than the chicken and egg question. Also, what came first, the circle or the wheel? I don't know. Look it up. Figure it out. Anyway, let's move on to what we're actually going to do. So, the standard form of a circle is the quantity x minus h squared plus y minus k squared equals r squared, where the center is the point hk and radius is the r. We're going to go through this example a little bit quick, only because, like I said, we did do this earlier in the year. You have done this before this year as well. So the expectation is that you actually know this already. So if I have the equation of the circle right here, x plus 3 quantity squared plus y minus 1 quantity squared equals 25, what do I know? I know my center is the point negative 3, 1, and I know my radius is going to be 5 because it's the square root of this number. So if I wanted to graph that, what would I do? I would come over to my graph. I would go to the point negative 3, positive 1. I would put a dot. That's the center. And then from there I'm going to go up 5, to the right 5, down 5, and to the left 5. And now if I connect those points, boom, a perfect circle. Okay, so what do we need to get from this? Well, we need to be able to recognize the standard form of a circle. So x minus h quantity squared plus y minus k quantity squared equals r squared. And from the standard form, we need to be able to get the center and the radius. Once we know the center and the radius, it should be pretty easy to graph a circle. What if something is not in standard form? Great question. So here we have what we call our general second degree equation. This equation is going to come up for all 4 of our conics that we're going to look at. You do not need to memorize the equation. You just need to recognize that it is probably a conic and how to identify which conic it is so you know how to get it into the standard form of that conic. Well, the key coefficients here, assuming this is a conic, are going to be the capital A and the capital B. So what makes the equation a circle, if it's a conic, would be that A equals B. Another way you could say that, if you want to be more precise, you could say A and B have the same value and the same sign. So if A is positive, then B is positive. If A is negative, then B is negative. and they have to have the same value, so 7, whatever it is. But A has to equal B. If that is the case, and it's a conic, which you may or may not know ahead of time, you're just going to assume it, then it would be a circle. So how do we apply this? Well, we want to identify the conic here. This is our general second degree equation. So we have 9x squared plus 9y squared plus 54x minus 36y plus 17 equals 0. Identify the conic and write the conic in standard form. Identify the key components of the conic. So for a circle, the key components would be the center and the radius. Well, since we're doing the lesson on circles, we can identify this. So identify the conic. It is a circle. How do I know that? Because the A and the B value are the same. Okay, what do I do to write the conic in standard form? So this process is going to be the same for all of our conics. What we want to do is we want to group the x's, group the y's, complete the square with the x's, complete the square with the y's, and then we will have our standard form. Now, you want to keep in mind the whole time, the reason why it's important to identify the conic first is so that you know what standard form you're trying to get this to look like. So my answer should look like this, because I identified that it's a circle. The other conics will have a different standard form. Alright, so first we'll rewrite this as 9x squared plus 54x plus 9y squared minus 36y, and then equals negative 17, because I want the x's, the y's, and then the constant is going to go over to the other side. Now to complete the square, what's the first thing we need to do before we complete the square? Well, we need the coefficient to be 1 for both the x and the y. Now, because these are both the same value, and this is a circle, I can do this all at once. For the other conics, you're going to have to treat the x's separate from the y's. But because here it's a circle, I can treat the x's and y's together. So what I want to do is I want to divide the entire equation by 9. So I'm going to rewrite this as x squared plus 6x. I'm going to leave a little space because I'm going to complete the square there, plus y squared minus 4y, leave a little space, equals negative 17 over 9. Don't forget to divide that by 9 as well. Now we're going to complete the square. What do we do to complete the square? We take half of the middle term and square it. Half of 6 is 3. 3 squared is 9. Half of 4 is 2. 2 squared is 4. If I add 9 to the left side, I have to add 9 to the right side. If I add 4 to the left side, I have to add 4 to the right side. Now, remember what you have created is a perfect square trinomial. So this is going to conveniently factor into x, whatever that sign is, plus, and half the middle term. 3 quantity squared plus, this will be y, whatever this sign is, minus, and half the middle term. Don't worry about that, that's just my chicken. Don't worry, let the beeping happen. Nothing bad is happening, I promise you. My chicken is done though. I look forward to lunch. Now over here, negative 17 ninths plus 9 plus 4, get a common denominator, simplify, and this is going to be 100 over 9. So what do we have here? We have our standard form. We can see that because it matches the x minus h squared plus y squared equals r squared. Keep in mind, this number here is r squared. It does not have to be a perfect square. It can be any value. So all of your numbers are not always going to work out nice. In this case, it actually does work out nice. You might not think so, but I do. So we want to identify our key components as well, because that was the last step. We know it's a circle. This is the standard form. We will circle that with a beautiful dashed purple line. And then we will actually write that the center is the point negative 3, because this is x minus h, so since it's a positive 3, that's negative. And then positive 2, because this is y minus k, so k is just 2. And the radius is the square root of 109ths, which is the square root of 100, which is 10, over the square root of 9, which is 3. So we will put another purple line around that, and that is our standard form, our center, and our radius of the circle. Now you try. So identify the conic, hint, it's a circle, write the conic in standard form, so complete the square, and then identify the key components. Pause the video, try this on your own, unpause when you're ready to check your work. Okay, so here we should end up with our standard form is the quantity x minus 1 squared plus y plus 2 squared equals 3. The center is the point 1, negative 2, and the radius is the square root of 3. Also, this was a circle. How did we get that? Okay, well, we identified it's a circle, so we know what we want our standard form to look like. So then I grouped the x's, I grouped the y's, I brought the constant over to the other side. Because the leading coefficient on x squared and on y squared is negative 3, I can divide the entire equation by a negative 3. When I do that, I end up with x squared minus 2x plus y squared plus 4y equals negative 2. Now I completed the square with the x's, so half of negative 2 is 1, 1 squared is 1. Half of 4 is 2, 2 squared is 4. Add that to both sides. Now I can go ahead and factor my perfect square trinomial, x minus half the middle term, so 1 quantity squared, y plus half the middle term, so 2 quantity squared, negative 2 plus 1 plus 4 is 3. So, what do we need to know? We need to know the standard form of a circle, what we can get from that, the center and the radius, and we need to know how to take the general second degree equation and convert it to standard form of a circle when it's a circle. So we also need to know how to identify when this is a circle, which would be if A equals